So then I should get a scooter.
It's only 7 minutes, yeah.
But like there is no exercise in scooter.
No.
It won't make much of a difference. Like
Yeah,
7 minutes.
yeah, I don't.
But maybe I can just like go circles around it.
Maybe so. Yeah.
Cause there's a the place that most about the Trump, there was a bicycle for 90.
Oh, a normal bicycle.
Yeah, normal one.
That's
this
good.
is 130.
What? She didn't pay 130.
She did.
That's a pricey scooter. I don't think I paid 130 for mine. Mine was more like 70 or 80. Maybe it's not quite the same as hers then. Where did she get her one from?
I have no idea.
Yeah. But she said there's a bike for 90. A used bike?
No.
It was on sale.
I don't know.
Well, that's very cheap. I think you won't get a better price than that. If you want a bike, you should get that one soon then, yeah. Okay, so where are we starting now? What do we want to have a look at? So, yeah, where will we start? What do we want to have a look at? Okay, let me park that there for a second. Let's just see what people want. Ray has some turning point, maximum, minimum questions here we could certainly have a look at. If that's what people want to have a look at, then Michelle?
Yeah, I'm still looking.
Yeah, sure, yeah. Mario, what do you think? What are you thinking there? Do you want to raise then turning point questions then? Yeah. We can practice these together. Yeah?
The question from last week.
What's the one from last week?
Was that the one he told you to read?
Yes.
Yeah, that's one. You told her to read for next week?
I absolutely forgot about this.
What question was that?
Global can be using the question.
Which page?
68.
We'll do these after that one question there. Yeah. Yeah, look, I remember telling you to wait until next week, but I can't remember the question. Which one was it?
There was no question. I was asking you to substitute any question in this formula.
Which page am I looking at?
It should be 68.
Is it 68? Or was it the one on 66? The 68, was it? Okay. Before we do these, let me do one at 68.
Using the formula.
First principles formula.
The slope of tangent formula.
Yeah. Okay, so let's take as an example on page 68. Will we do easy or hard one? What?
Hard.
A hard one? Yeah, that's right, yeah, you keep quiet. How about we just say 4a as an example, okay? So you have y equals 5x squared minus 3x plus 5. And we want to calculate dy dx. So we need to use the formula here, fx plus h. Right, who will I pick on? Mariam, I'll pick on you. So do you remember the formula, fx plus h, and then something and something? Notice Mariam now? See if she remembers.
X plus
Yeah, what?
X H.
No,
Open bracket.
no, no,
X.
no, no,
N.
no. But plus or minus next?
Oh, plus. Plus.
Minus, yeah, yeah. Maybe, Michelle, do you know the formula, this one? You know the first principles formula?
It should be minus FX
Very good. All over?
over H.
There, go. Okay, alright. You know this formula?
I remember, but I just forgot it.
Yes, okay. You remember doing it anyways,
Yeah.
yeah. Right, so,
I don't remember this one.
have you not done it in class yet? It's on this page, 68. Have you covered this page? Oh yeah, that's that page there, yeah. Which page are you on?
I remember the idea.
You need this for the exam, so you should write this down carefully, okay? Right, next now. This is 5. So Alfreda, this was your question, wasn't it? So what do I write next? Could you maybe tell me? So I'm taking this and I'm replacing the x. The x is getting replaced with x plus h.
Oh,
Yeah. So what happens next?
that's X plus H
Yeah.
squared
Good, yeah.
minus 3
Yeah.
X plus
Good, yeah.
plus 5.
Good, okay.
That's it.
Oh well, there's still more to go, but that's the main idea. Yeah.
The substitution I was confused about.
Was that the only part you were stuck with?
That's what I was.
Ah, alright.
I didn't know what was happening.
Yeah, okay. Good, alright. Shall we finish it now? Yeah. Okay, Angela, what's next now? Ah, well, if I'm continuing from this formula, so I've just done this part.
Yeah, okay. Minus 5x squared.
Yeah,
Plus 3
yeah.
minus 5
Okay, all over
h.
h. Okay, Aria, what should I do next now?
Open it.
Yeah, open the brackets then. So that'll be 5.
X squared.
Oh wait, one sec. Yeah.
Why is it 5x squared plus 3x minus 5?
Yeah. Who did that part? Angela, you did that part. So why do we have minus plus minus here? What was the reason for that?
Because we are subtracting the f of x. So we just change all the signs.
Yeah, we're minusing this guy. So do you see? Can you imagine I put a minus in front of this?
Yeah.
So it'll be minus that one plus that one minus that one. So it's like this sign. This flips all the signs when you put in the fx. Now, if you're not happy with that, what you can do instead is you can leave the minus here and put brackets, and then just write the same thing. You know, and do it in 2 steps. So if you want, you can just put in brackets, but you can save a bit of time by just writing it down directly, but flipping the signs around. Okay, so Aria, wasn't it? You were telling me what comes in next. So what?
X squared
Yeah.
plus 2x
Yeah,
plus h squared.
yeah, and well, this one is 3x minus 3h. Okay, and they're all the same, aren't they? Okay, Michelle. Oh, sorry. Yeah.
Where did it come from?
Oh, this part here.
No, that's too quick.
This
I guess,
one.
Did I find it?
Yep, expanded. Yeah. Okay, Michelle. What do you think I could do next here to this? Something I still need to do on the top, I think. Yeah. What about here? What could I do next? Yeah. Yeah. Multiply everything with the 5 then. So that's 5x squared plus 10hx plus 5h squared minus 3x minus 3h plus 5 minus 5x squared plus 3x minus 5 all over h. Okay, Ray, let's see, how many x squareds have I got? So I have 5 here. Do I have any more?
You have the negative 5.
Negative 5. So in total, what have I got?
Nothing.
Nothing there, okay. What about x?
That's one.
I've got this one, haven't I? Yeah, what else have I got? I've got 3x, minus 3x.
And then plus 3x.
Oh, plus 3x. Alright, well that's nice because those cancel. So I'm just left with 10hx. Okay, and what about think that was a plus actually. Yeah, it was a plus.
It,
Was it a plus? Wasn't it? That one there. Plus 5h squared. Plus 3h, was it? No, that's, sorry, my writing's a bit bad. That's minus 3h, isn't it? And then I actually, sorry, you can't quite see, but there's a 5 here and a minus 5 here, and they cancel as well. So actually, I'm just left with these three things, all over h. So Angela, what could I do next to this one?
take h outside.
I could take h out, yeah, or in effect divide by h, yeah. So h over h is gone, so that's 10x, and then what would this one become? 5h, and then at the end?
Minus x.
Oh, that's sorry, that's a 3. Yeah, minus 3. Yeah. And who knows the last step? Yeah, go ahead, Arya.
Limit h tends to 0, so 5h becomes 0.
That's it. So you make the h 0 at the end, and you're left with 10x minus 3. Yeah, it is part of the formula, the definition. I should have written it at the start, but it's this, and then you make h go to 0 at the end. Do you remember what that's called, Alfreda? That's called the limit. You know, when you write the little lim in the front, h going to 0. Yeah, okay. Now, did I tell you what the value of x was in the question? I did. What's the value of x, Alfreda? If you can see it, minus 3. So, substitute it in. That is minus 33. That's the answer. Okay. Now, that is the absolute hardest question they could give you in the exam on first principles, because in the syllabus it says in the exam students will get at most a quadratic. At most a quadratic. Often my experience is they actually give you a small quadratic, like they would give you something like this only. Not even with the extra pieces, you know. So it's actually good to know. It's good to practice this hard one, because then it makes something like this in the exam seem very easy, you know. Okay, now if there's no more questions in the book, Ray has some calculus questions we can practice here. Oh, you have some on the back as well. Nice. And the ones at the back, they look harder. So how about we do some of the easier ones, and then we can do one of the harder ones then. So we'll warm up with some easy ones at the front here. Okay. You can tell me. No? What's going on? Nothing I need to worry about? Okay, good. Right. We want to find the turning point. So let's do the first one here. Okay, so Ray, before we start, do you have any ideas on how to do it? Now, you don't need to know how to do everything. Just I'm wondering what ideas or what do you know here?
Oh, I forgot.
Yeah, that's okay. Yeah, it's you're looking for something called the turning point. So the turning point is this point here on the graph, the lowest point or the highest point, depends on the graph. And we can use calculus to help us find that. The trick is to get the derivative of this function. Okay, so Michelle, what's the derivative of x squared?
That's 3x.
2x. Now can you tell us what rule you're using? Like, how did you get 2x? What's the rule here?
Bring down the power to the left.
Yeah, so you bring the power down to the left, and then what happens next? Yeah, it's the 2 minus 1. Yeah, so that's like power 1 here. So the rule is you bring the power down, and you take 1 away from the power. Now, Mariam, do you know what the derivative of 6x is?
Minus 6.
Minus 6. And what kind of rule are you using there?
We just took away.
You just take away the x. So when it's simply just a plain x, you just use the 6. Yeah. Yeah. And what about the 5? Alfreda, do you know what happens in 5? 0. So what way would you express the rule that you're using?
I know when it's a whole number
Yeah.
that doesn't have x.
Yep.
It's automatically 0.
That's it, exactly it. So when you have numbers with no x's, it's automatically 0. Very good. Okay, now that we have the derivative, the next part is what? Mariam, do you know what to do next? If we're looking for the turning point.
Find that.
Yeah, but I have to make this equal to something to find x. That's it, 0. So you get 2x equals 6, x equals 3. Now, Ray, if I have the x here, how could I find the y?
You replace
That's
the
it.
3.
Replace it in here, yeah. So you will get y equals 9 minus 18 plus 5. So what's that? 14 minus 18 minus 4, I think? Yeah. Okay, so we'll warm up with that one now. But let's jump down a little bit. Let's make it a little bit harder now. Yeah, the question was find the turning point. So I wanted the x and the y. Yeah. Is it okay? No. Okay, good. Tell me.
I know the other time you said something about you look for y prime, then you look for y prime prime. So I don't know when.
Yeah, when do you need the second derivative? Is it the y prime prime?
Yes.
So that's the second half now. The second part is state if it's a maximum or a minimum. Now you already know the answer from the picture I drew. Is that turning point a minimum or a maximum on the graph?
Minimum.
It's a minimum. So we kind of know the answer already. But we need to check. And the way we check is by getting the second derivative. So let's see, Ray. Michelle, Mariam and Elfrida explained the rules. So let's see if you can remember. What's the derivative of 2x?
X squared.
No, not that one. Now, who gave us that rule? Mariam, you gave us that rule. So, what's the derivative of 2x? 2. And what's the rule that you're using? How did you explain it?
Take away the x.
Yeah, when it's just simply an x by itself with a number, you just take away the x. That's 2. And then what do you have next then? What does the 6 become? Would you know? I think, Elfrida, you gave us that rule. What happens with the 6 when you get the derivative?
Oh, just know that any number you see there, you might not it by 1. So 1, sorry.
You're confusing yourself. You knew this a few minutes ago. The derivative of minus 6.
Oh, okay. Any whole number is equal to.
That's it. Any number is equal to, any number without the x is equal to 0. So that minus 6 is gone. Okay. Now, to check if it's max or min, your answer here is either a positive or a negative. So the number 2 is positive, obviously, plus 2, and that corresponds to minimums. If you have a positive second derivative, that means you have a minimum, and if you have a minus, that means you have a maximum. Now, that's not shocking news, because we knew already that it was supposed to be a minimum from our picture, but we've now confirmed it. Okay, we'll do another one, alright? We'll do another one. Can I scroll down? Yes, I can scroll down. Okay, so let me jump down to one that's a little bit harder, but nearly the same. So suppose I say, yeah. Yeah, you only care if it's positive or negative.
Okay.
So, you know, even if it was 202, it's as long as it's positive, yeah. Okay. Next now. Y equals x minus 3 times x minus 5. Okay, now this one is a little bit different, isn't it? It's not quite as friendly as the last one. Mariam, any ideas on what we could do first?
Expand.
We should expand it, yeah. So x by x, x squared. X by minus 5, minus 5x. Okay, Michelle, what's next now? So I've done the first two. I've done x by x and x by minus 5.
3 by minus 3 by x.
Yeah, so that's minus,
3x.
yeah, and then lastly,
Minus 3 and 5.
yeah, yeah, so what do I get here? Plus 15. Right. Okay, Ray, give me the derivative here. What does x squared become?
2x.
Good. What does minus 8x become?
Minus 8.
Very good. And 15?
0.
Good, good. And what does this equal?
0.
Good. So, if we solve this, Arya, what do we get here for x?
4.
We get 4 then, yeah. And, Alfreda, how can I get the y? Sub it in. Back into the original here. So you'll get y equals minus 1 then, when you sub it in. Yeah? Because it'll be 4 minus 3. What's 4 minus 3? 1. Multiplied by 4 minus 5, which is minus 1. Yeah? Okay. Now, let's get the second derivative when you're ready. I'll pick on you again, Ray. So give me the derivative again of this. So 2x, what does that become?
That will become 2.
Good, good. And minus 8?
0.
Now this is a positive, isn't it?
Yeah.
And does that mean we have a min or a max?
Min.
Very good. Okay, so I reckon, Ray, that means you should be able to do questions 1 to 8 on this, because they're all quadratics.
Alright.
But we'll do a cubic now.
Okay.
Are you finding this? This is helpful revision. Number 9 is a cubic, and that's a very common exam question, is the cubic. The reason they like the cubic in the exam is because it has 2 turning points. You know, and in fact, often the cubic is a section B question, which I think is quite generous, because you know section B questions are supposed to be harder, but this isn't too hard to do. Okay, so let's have a look at the cubic now. Right, y equals x cubed minus 3x squared minus 24x plus 10. Now this is question 9, and if any of you want a copy of this revision sheet, Ray got it from his maths teacher. I'm sure you wouldn't mind letting them take a picture of it. So if you wanted more calculus practice questions here. Okay, so I'm going to pick on you again, Ray. Can you give me the derivative here?
x2.
Yes, you're nearly right.
3x2.
Excellent. Next.
Next will be negative 6x.
Next.
Negative 24.
Good. Equals?
0.
Good. So far so good, right?
Yeah.
Okay. Now, question, Alfreda?
No.
You sure? Okay. Angela, what could I do next to this? What would be a good next step here for this one?
You can divide the entire equation.
By what? What number? 3. Yeah? Can you see that? I can divide everything by 3. So, Alfreda, what do I get here if I divide by 3?
You have x squared.
Yeah, I'm dividing everything by 3, so we'd have x squared, yeah. Next?
You have 2x.
Next?
Oh, you are asking?
Yeah. You sure? Yeah. Minus 8 then equals 0. Okay, now, what type of problem is this? Michelle, what do you call this problem? Quadratic. Do you want to factorize? Why not? Let's try to factorize it. So we need 2 numbers that multiply to make minus 8 and add to make minus 2. So what possibilities could we have? What multiplies to make 8? You could have 1 and 8, or 2 and 4, or 4 and 2. So it's not likely to be 1 and 8, because I can't really add 1 and 8 to make it 2. It's probably 4 and 2. Now we have to choose the signs carefully.
Negative 4, 2.
Very good, Ray. Minus 4 and plus 2. So my x here is minus 2, and my x here is 4. Alfreda, you don't look happy with that.
You equate it to 0.
Yeah. It's okay? Okay, alright. You just didn't look, you looked very serious at it. Okay, Ray. Oh no, I keep picking on Ray. Mariam, what do you think I should do next now?
Put both the x.
put both of these into the original here to get the y's, yeah? Could you do the first one, please, the -2? And Arya, could you do the second one, please, the 4?
That's -70.
Minus,
70.
okay, like this? Yeah. And now make sure you use brackets, okay, for the -2, yeah. They're not too bad, are they?
No.
No.
38.
38. Okay. Angela, what would we do next now?
To find the maximum and minimum.
Yeah, so what would be the next step?
So we find the second derivative.
Second derivative. Will we ask Ray again for the second derivative? Yeah, because you want to practice, right?
Okay.
So go for it, Ray. Impress us. Second derivative now.
Alright.
So, yeah, this one, yeah.
6x
Yeah,
with -6.
good. And then that's it then, yeah. Now, Alfreda, what should we do next? Now that we have the second derivative, what should we do next?
We have the second.
Yeah, we have the second derivative here. So what's the next thing I should do? Yeah, like what's my next step? I'm trying to figure out which of these answers is the maximum and which is the minimum. Yeah. If you don't know, that's okay. I'm just wondering if you know. No? Marion, would you know what happens next? Yeah, what's my next step? If I'm trying to figure out which of these answers is the max and which is the min, how can I use the second derivative to do that? Yeah, it's not as easy as the last one, because in the last one we kind of stopped when we got the second derivative because the answer was just 2. But what's different in this question? The answer is not a number, is it? It's actually a formula.
Do we go again?
Ah, nice try, but no. Oh, you mean like again and you get 6 then?
Yeah.
And life would be happy then. Yeah, not this, I'm afraid. Not this. Michelle, would you have an idea what to do next?
I'm thinking.
Yeah, I'll tell you. No, go on. Yeah, substitution. What do you think? Yeah, what are we going to say?
Yeah, I was thinking of substituting. But
Yeah, no, be confident now. Tell me what you're thinking.
that's what I'm thinking.
Okay, so I should substitute what and what?
Value of x into.
Yeah, okay. Now, since you had trouble with this, just listen to what Michelle is saying here. You take the value of x and you put it into the second derivative. So here you would get 6 times -2 minus 6. That's minus 18. Is that positive or negative? Negative. So that means this answer is a maximum. And
that one's a minimum.
it's likely to be a minimum, yeah. So you take this 4 and you put it in. 6 times 4 minus 6. 24 minus 6 is 18. Is that positive or negative? It's positive, so that means this one here is a minimum. So the final answer is -238 max, and then 4 minus 70 min. Is that okay, Alfreda, or are you sure? Okay. I will do. Yeah. Right, before we do a hard one on the back, let's do one more of these ones here. Yeah. Can I scroll down? Yeah. Right. 20. Y equals 1 minus a quarter x minus 4 over x. Okay. Michelle, if we were looking at this equation here, there's kind of a problem with it. There's something we don't like about it. What would you say that might be? Like, how is this harder than what we've been doing so far today? Or Ray, if you can see it too, what's,
The factor?
The position of,
yeah,
um,
yeah, the position of x. Like, what is making us unhappy here, Mariam, about this one?
The fraction.
It's a fraction, but in particular, it's the fact that x is in the denominator. So we should do something about that to begin with. So we should change this into a power. Alfreda, do you know what this becomes if I write it as a power? Before x, what power? You're thinking of square root. Yeah, it's not 1 over 2. Square root is 1 over 2, yeah. What about 1 over x? Do you know what it is, the power? Minus 1, yeah, minus 1. Yeah, is that okay? Yeah. You were right, the square root x is a half, and then 1 over x is minus 1. Okay. Michelle, what's the derivative here?
so,
Oh yeah.
can we take the LCM instead of 4x as an LCM? Or multiply by 4x all the terms?
Sadly not, because that would bring an x on the left, which would be quite a disaster, because we can differentiate, we can say y becomes the y dx, but we can't say xy becomes, yeah, so sadly not this. Michelle, derivative here, what do we get? Yeah, this one is 0. Yeah. And then what does this become? Nearly, it's just minus 1 over 4. Yeah. Yeah. Because like you were saying earlier, Mariam, when you have a number and an x, you just drop the x. So that becomes minus 1 over 4. Now, Alfreda, what would be the derivative of the last one here? Minus 4, just minus 4? Of this guy?
Oh, sorry, minus 4x.
What power?
0.
Are you sure?
1 minus 1.
Minus 1, minus 1?
Minus 1 minus 1.
Times 2. And you bring the minus 1 down, so it's actually a plus. Okay. And what should this equal? 0. Okay. Mariam, what could we do next if you have any ideas? Yeah, so what could I do to kind of get towards that?
So 4x to the power minus 2 equals 1 over 4.
Okay.
And then you divide by 4, so...
Yeah. Get 1 over 16. Okay.
And then you
Yeah, that's getting harder.
root it. You root both sides.
Not nearly, not quite. One step before you do that. We have x to the minus 2, not x to the 2. So what's the effect of the minus, Alfreda? What does minus mean in the power? Yeah? Yeah, over. So this is 1 over x squared equals 1 over 16. Okay, now what did you suggest to do next, Mariam? You root both sides. You root both sides. So this becomes over, and this side becomes, yeah, but plus or minus when you square root. So what would you say x equals then? You know, if I said 1 over x equals 1 over 4, what's x? It's not a trick. Yeah. Yes. Yes. You're just not sounding sure when you're saying it. X is 4. And if I had minus 4 here, x would be minus 4. So x would be plus or minus 4. And then I need to get the y. Oops. Michelle, could you put 4 into this? And Mariam, could you put minus 4 into this? Well, actually, maybe we could do it in our head. 1 minus 1 is 0. Minus 1, I think, is the first answer for y. Or, and we put in minus 4. 1 plus 1...
9 over 4. Yes.
9 over 4?
4.
What?
Oh, sorry.
1...
3.
Yeah, okay, that sounds better. 3. Yeah? So you have two answers, 4 minus 1 or minus 4, 3. But we need to figure out which is the max and which is the min. So Arya, how do I figure that out?
You substitute in the double derivative.
Yeah, which we haven't figured out yet. So Angela, what's the second derivative here? So we're differentiating this line.
So 0
Yep,
plus minus
yep,
8x raised to minus 2.
good. And then what do we do next that we have that?
Oh, me?
Yeah,
Oh, to substitute the...
that's it, yeah. You sub in 4 and minus 4. So let's pop in the 4. What's it going to be? It's going to be something like minus 8, 4 minus 3. I don't need the calculator. I can tell it's negative. So that means this one is the maximum. And then I sub in minus 4, right? So that would be minus 8 minus 4 minus 3. That guy works out to be positive because you have minus minus. So that one is the minimum. And that's it for that one. That was number 20 on this page.
So can you explain
Which,
when the calculation there?
this one?
No.
This one?
When before we decided the square root and stuff.
Before the square root?
Yes.
Here?
Yes.
Okay. How did I go from here to here?
Yes. Wow.
Mariam, tell us, how do we go from this line to this line? You suggested this.
Oh, divided by 4.
You divide it by 4. Is that okay? So the 4 comes down with the other 4, makes it a 16. Yeah? Yeah. Is that what you needed to check? Yeah?
Yeah.
Okay. Alright, you wrote this down? Yeah? Okay. Now we'll finish up on a hard one. These ones at the back actually are quite hard. I think this one is alright, but these ones at the back are they're very tricky actually. So can I scroll down? Okay.
You get these very tricky ones.
No, actually, in the exam, they're often like cubics in the exam. It's the most common type to give is a cubic in the exam. The odd time you might get something tricky, but 90% of the time it's something straightforward like a cubic. Okay, so we have a curve y equals x cubed plus ax squared plus bx plus 11. Yeah, it's like that. And it has turning points at 3 minus 70. But actually that's just a turning point. Okay. So they want you to first figure out an equation, part A, an equation that contains A and B. Now, what have they given you? They've given you an equation for y, yes, and they've also given you 1 point on this cubic. So, yeah, you have a cubic and they've given you a point on the cubic. So what could I do to try and make an equation with A and B? Let's see. Alfreda, you seem like you might have an idea. I know what's gone. Yeah. Yeah. Putting it in, yeah. Put the x in, and then what about the minus 70?
We put it outside.
Yeah.
Because they knew us.
Yeah. So I was right. I could see that you knew this. I could see the answer was inside you. So you have minus 70 equals 3 cubed plus a times 3 squared plus b times 3 plus 11. Yeah? Okay. What's 3 cubed? That's 27. and 3 squared is 9, and 3 is 3, and 11 there. Okay, Ray, what could I do next to clean this up?
Find all ones of the same size.
Yeah, so what should I move to where?
Should move the 70 to the other side.
Bring it all to the right. Yeah, I could do that. I kind of like the A and the B to be on the same side and the numbers to be on the other side. So I could bring this one to the left. And what about this one? Also the left, yeah. So minus 70, minus 27, minus 11. Could you hit that in, please, Ray? Tell us what you get there for those.
Minus 108.
Great. Now, is there anything I can divide here? Can anybody see anyone? 3, yeah. Yeah, 9 is a little too big. 3. So that would be 3a plus b equals something. 30, what? 36, is it? Okay. Right, that's the answer to part A now.
I thought you wanted the individual, like,
Yeah.
B equals to this, A equals to this.
We will, we're doing this in steps. So in part A, they just wanted the equation. We're working up to get the A and the B, yeah. But you're right, the overall idea is that we get to the A and the B at the end, yeah. Okay, part B, find the derivative and use this equation to make another equation with A and B. Okay, part B, Mariam, can you give us the derivative here of the original?
3x squared
Yeah.
plus 18x.
That, believe it or not, is an A and not a 9.
Sorry.
Yeah.
Plus 2ax
Yeah.
plus b.
Good. Now, if we're talking about turning points, this should equal 0. What can I do next to make another equation? Michelle, any ideas? If I pick on you, what could we do next? Kind of similar to what we did in part A. Yeah, what were you saying? It's something with the tree, was it? Yeah. How did we get this equation? What did we do? Alfreda, what did we do to get this equation? It was your idea, remember? What did we do?
Oh,
We substituted this
the
in.
information they gave us already.
Yeah.
They gave us Y and they gave us X.
Yeah.
So we just put it inside the equation.
Yeah. So what do you think we can do next now in part B? Could we do something similar? Why not? We have the same point, it's still true, and we have another equation, don't we?
Yes.
So, why not? We'll sub it in. In fact, this equation doesn't have a y. We only have to bother with putting in the x. So, this will be 3 times 3 squared plus 2a times 3 plus b should equal 0. 27 plus 6a plus b should equal 0. So 6a plus b should equal minus 27. Well done! Simultaneous! Yeah, well done. So, Alfreda, you're going to tell us what to do to solve this simultaneous since you've spotted it. So what should I do?
Oh, I think you should multiply one of them with minus to eliminate B.
Eliminate b, yeah. So we can just minus them.
Oh yeah.
Yeah. So 3a minus 6a is minus 3a. And then b minus b is gone.
Yeah.
And then minus 36 minus minus 27. Do you want to hit that in on the calculator, Alfreda? Minus 36 minus minus 27. Is what, minus 9?
Minus 9.
So if I divide by minus 3, my final answer is 3. Okay, and Angela, how could I get the b now?
You can substitute
Yeah, which one do you think would be the easiest one to go for?
3a plus b equals 1.
Yeah, looks a little bit easier, doesn't it? So if we sub it into this one, yeah? So you have 3 times 3 plus b equals minus 36. So b is let me slow it down a bit. So 9 plus b equals minus 36. So b equals minus 36 minus 9, which is minus 45. Good. So we've worked out the a and the b. Yeah? Okay. So let's go back to the original question now. Y equals x cubed plus ax squared. And what did we say a was? There it is there, isn't it? 3. So plus 3x squared plus bx. And what did we say b was? Minus 45. Plus 11. The final question is, decide if the point that they gave you at the very beginning, 3 minus 70, decide if that's a minimum or a maximum. So, Michelle, how could we figure out if this is a min or a max? What do we do to figure that out? Subbing into what now?
3 into x and 74.
Not quite. We have to work out something first. There's something I don't have yet that I need for deciding if something is min or max. Would you know, Mariam? Yeah. The second derivative. We need the second derivative, okay? So let's get the first derivative. Okay, Alfreda, what's the first derivative here? Let's see how quick you can do it. Go for it.
3x squared.
Yeah.
6x.
Yeah. Minus 45, yeah. And Ray, what's the second derivative here? The next derivative.
6x.
Yeah.
6.
Plus 6, yeah. Now, Michelle, what should I do now? I have the second derivative. I have my point. I want to know if it's a max or a min. Subbing it in, yeah? So if I sub in what? The 3. So that's 6 times 3 plus 6, which is 18 plus 6, which is 24, which is a positive. So, Alfreda, is that max or min? Min, very good. So that's min. So it was a minimum. Yeah. And that's actually that's kind of the hardest they can really make it in the exam. So this is a good worksheet because it's a kind of a good mixture of difficulty. Starts off at easy, gets to the hard ones at the back. Do any of you guys want to take a picture of this to practice? Do you want to pass it around? There's 2 sides on it, okay? They're good practice questions for what we were doing this week. When do you need to have this finished by? Before the weekend?
I think it's for the weekend, yeah. No, not the whole worksheet.
I gave you some questions from it.
I think the whole first page.
Okay. Yep, we're finished there, so. These classes are all on the YouTube page as well. There's a playlist for them.
Have you done any trig questions?
Did we do trig last week?
Yeah, we did.
Did
I
we?
think. It's kind of very. Yeah, we did.
I have no memory of last week. Did we do trig last week?
Yeah.
We did the trig graphs last week, didn't we? Yeah, the graph. But I don't think we actually did any.
Oh wait, never mind. Because I remember you saying we did so much trigs, so I'll leave it here. So I think that was the.
That was the tutorial in
Yeah.
the big class. Who was asking me for trig? So I don't think these extra maths videos will have. Last week's video, we talked a lot about the graphs. We talked a lot about the graphs. We did quite a few examples. So you might have some value in that.
Yeah. If you're doing trig next week,
I don't know what we're doing next week. It depends what you guys feel like doing next week. Because you want to do some trig next week? The practical problems. Yes. We'll have to find some more questions though, because we did all the ones in the book. Doesn't matter if we do it again? Okay. Well, do you know what actually? Maybe we'll have a look at some trig exam questions if that's what you want to do next week. Trig exam questions? Yeah, okay. Alright, we'll do that next week then. Is this lecture 8 or 9 like that? This one's 8? Yeah, okay.
can we come?
It depends if the other students are going to show up. We'll see next week. Yeah. Yeah, but she'll have the video afterwards too. So.